although we consume a lot of legumes in our diet, I wouldn't say on the animal agriculture side of things, we have really investigated, and I say that, but it started to ramp up, especially over the past 10 to 15 years, that we've investigated the milling and processing of pulses for agriculture feed. We know a lot more about it on the human side of things, but there's still a lot to know, especially in inclusion in ag diets or even companion animal diets.
Hello from North Carolina State, and on behalf of Wisenetics, I'm Adam Fahrenholz, and this is the Feed Science Podcast. I'm joined today by Cara Cargo-Froom from the University of Guelph, and she is a postdoctoral researcher there. Welcome, Cara. Great to have you.
Thanks for having me.
So as we do with everybody on our podcast, we've got folks that are coming to us from kind of the more nutrition side or the processing side. And so we always want everybody to introduce themselves to the audience and let us know a bit about your background, how you kind of came to be in this particular area. And then after that, we'll get into a little bit of what you're up to now and see where that conversation takes us. So if you would, Cara, give us a bit of background on yourself and how you came to be in the position you're working in today.
Yep. So I did my undergrad at the University of Guelph, didn't go very far. I mean, being in Canada, obviously I wanted to be at the top school for agriculture. Thought I wanted to be a vet, and then fell in love with nutrition, and that kind of took over my world. So I actually ended up starting and completing a master's with Dr. Anna Kate Schubler on companion animal nutrition, and then flipped over to some protein quality and swine work in my PhD. But within my PhD, that's where I actually had a processing study kind of fall into my lap and entered the world of feed processing a little bit more than just, we're making an extruded diet. This is what we want into the diet. So I ended up kind of falling into that feed processing world by accident, but I like to think of it as a happy accident because really I've now been able to follow feed ingredients from the very beginning of us sourcing them all the way to feeding them through my animals and measuring those outcomes. In my postdoc, I'm not actually working with feed processing per se in a study, but when you look at it, feed processing, really there are different aspects that can influence nutrition and digestibility, et cetera. So although I'm working on in vitro digestion, for example, we're still going to look at different feed ingredients and their processes as well. So although, for example, we tend to feed just forage to horses, they might also get forage cubes or pellets, which are, again, processed differently. So although they might not be exposed to extreme temperatures like extrusion is, there still might be some change, whether that's particle size, et cetera. And so we can kind of take those into consideration with my study. And so that's where I'm at in the feed processing world right now.
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
Excellent. Yeah, I think that description of happy accident has been used a number of times in describing how many people ended up in this particular area. It's not something, not a whole lot of people necessarily just kind of, what I always wanted to do was go into feed milling, even if it's something that you knew a little bit about, it's something that people fall into. And then hopefully we capture some folks like yourself that decide, hey, there's some interesting stuff here and I'd like to be involved. You just mentioned you're working on equine things now. I believe in your previous work, you also did a lot of things with swine and you were working with pulses. And that's probably something that's a little different than what most of our audience would typically work with or feed or understands a feed ingredient. So can you describe to everybody what some of that work was like? First of all, what pulses would be, what those represent, and then what some of your work there was?
Definitely. So you've asked me a key question. What is a pulse? I think I've answered this so many times, but I also can't stop talking about them. So a pulse, everyone knows what pulses are. You just don't know that you know what a pulse is because we don't hear that terminology a lot. But what a pulse is common legumes that we are eating in our diet every day. So these include legumes like our broad beans, our faba beans, kidney beans, navy beans, chickpeas, lentils, and then some other lesser known legumes like vetches and lupins. Now, fun fact is that not all legumes are pulses, but all pulses are a legume. So you have legumes like soybean, which is another common legume people are very well versed in, but it's not actually considered a pulse because it's an oil seed. So you have that categorization, but pretty much a pulse is a legume that's consumed for its dry seed. And so that's its primary purpose for harvest. And although we consume a lot of legumes in our diet, I wouldn't say on the animal agriculture side of things, we have really investigated, and I say that, but it started to ramp up, especially over the past 10 to 15 years, that we've investigated the milling and processing of pulses for agriculture feed. We know a lot more about it on the human side of things, but there's still a lot to know, especially in inclusion in ag diets or even companion animal diets. I won't go down the DCM route, but I'm sure everyone heard that with the FDA associating DCM with diets that are grain-free, which tend to be diets high in pulses. Now, there's a lot of information out there that people can go check out. What they've concluded is really there's no hard conclusion that pulses were at fault. And that's what I'll say on that, because that's not what we're here to discuss. But it really brings in that discussion of feed processing and what we include in feed.
Sure. So for those that aren't familiar with the terminology, although like you just said, Cara, I'd imagine most people in our world probably are, DCM would be dilated cardiomyopathy, which is something that has happened, effectively a heart problem, and it was mostly dogs, was probably a little overly optimistic. And there was a whole bunch of things related to feeding grain-free diets and then where was the protein coming from, and it could be from this, and it's likely one of those statistical things where everybody focused on one thing and it must be this, but it was a situation or is a situation where no, there's a lot of things going on when you would choose to formulate in this other way that could have an impact on what's happening in the animals. And so there's been, like you said, no direct ties. And I think that's an important distinction that you made.
Exactly. And yeah, that was just an example to bring up because I think a lot of people understand that. And like when we talk about pulses, which is maybe a newer feed ingredient, even those on the ag side, many people have dogs. It was a big discussion. So I think it's a nice lead into our pulses.
Sure. So let's talk a little bit about let's do some benefits and some what would we say, some things that make it hard to use. So let's start with the benefits. What would be the benefits of using pulses in feed manufacturing for various different species?
So I see a bunch of benefits, including for humans. We do this less so on the animal side of things, but in the human world, we're fractionating a lot of these pulse ingredients. And so for those who don't know what this fractionation is, it's where we're splitting it up into its individual components. So we're trying to isolate the protein components, or we're trying to isolate the fiber components. So we end up with these kind of rich protein isolates or concentrates that are primarily protein. And then we're left over with this more fibrous hull, for example, or even, for example, processing. So to break up that hull, which is going to be harder to digest for an animal, by grinding to a finer grind size, we allow more access to those more nutrient-rich inner portions of the seed. So there's lots of positives in feed processing for pulses. Another one is, if we look at the human side of things, but this applies to animals as well, pulses must be processed in some form. And that's because they contain a lot of anti-nutritional factors. And when eaten, especially if consumed in their raw form, for example, lecithins are quite common, and that can affect red blood cells. It can cause hemagglutination. Then you have, for example, trypsin inhibitors, and these are going to inhibit how protein's digested in the small intestine. And so that protein and subsequently those amino acids that the protein's digested into become less digestible, less available because we aren't digesting those proteins appropriately. So in terms of processing pulses, there are lots of benefits because not only can we get individual fractions that can either be used as a byproduct in, say, animal food or in the human world, we're also generally improving the nutrition by helping reduce these anti-nutritional factors. And this doesn't have to be on a large scale either. For example, soaking and boiling pulses at home significantly reduces many of the anti-nutritional factors associated with protein digestion. And so we see both on a large and a small scale of food processing that we've got these improvements. Now, sorry, go ahead.
No, well, I was just going to ask, so in kind of your research and maybe even in the beginnings of your looking at the utilization of pulses, where would you put the kind of if you had to balance how much of it is an interest in going after specific nutrition and how much of an interest of it is in something from an economical perspective, as in these are out there and they provide something at an least cost type of a situation in comparison to other ingredients that might be available?
I would say both. Now, the one downfall with pulses is that they tend to be limiting in certain amino acids. And by limiting, they can be severely limiting, so that when we look at, say, a protein quality score, they fall lower than our animal-based proteins. Now, this is quite common for almost all plant-based proteins. But what's nice about pulses is you can complement them with other ingredients, such as grains that tend to be richer in the amino acids that pulses tend to be deficient in. So it's why they're considered complementary ingredients. And this is what we see with vegetarians a lot, where you eat rice and beans, you now have this complementary ingredient mix. And now you have a balanced amino acid profile in your diet compared to just eating pulses. So on a nutrition side, there's many benefits. Now there are some downfalls, such as those limiting amino acids, but pulses are rich in carbohydrates. They're rich in both soluble and insoluble fiber. They're an excellent source of B vitamins. They provide bioactive compounds such as phenols, which can have antioxidant properties, etc. So to me, the benefits of consuming pulses outweigh the negative when you think of the limiting amino acid aspect if you're eating a balanced diet. In terms of animals, again, they have the same effect generally for animals as they are going to have for humans. We're seeing those nutrient-rich benefits, especially, say, in terms of fiber. And then on the economic side of things, when we think about pulses, they are they're quite blanking on the word I'm looking for, but they're a hardy crop, so they have less water needs. They tend to just take water from the surface of the ground rather than further down, which means that we can leave water in the water table for longer growing rooted plants. They're nitrogen fixing, so when you include them in crop rotation, they're fixing nitrogen back to the ground. They're very hardy, so originally kind of started in the Middle East where there's not a lot of water. And so these plants can grow even during droughts and harsher climates. So in Canada, we actually grow a lot of pulses out west where maybe they don't necessarily get the same amount of rainfall. And from an economy side of things, they can actually be more economic than some other ingredients, especially if we're competing in different areas of nutrition. So that's also something to consider, is it's not so much the cost of the crop itself, but also what's the demand for it. So if there's more high demand for soybean now in humans, how are we going to accommodate for that so that we don't have competition between animal sectors and human sectors for high quality proteins that aren't of animal sources? Well, enter pulses. We can help spare those effects by including pulses. And it's not to say that they're going to completely take over a category, but it can help support both human and animal nutrition.
Okay, so we've got some nutritional benefits there. We've got some, potential economic benefits, as well as some sustainability things, which is something that everyone's looking at in their formulation practices, processing practices, all those kinds of things. Okay, so now we take the pulses and we take them into the feed mill, and beyond the typical, what do you mean I now have to figure out how to have another ingredient in my feed mill? I've run out of bin space and I've run out of, ability to grind and everything else, because now you want to add another ingredient to my table. Beyond that particular part, what kind of things did you guys find as far as any benefits or any difficulties with including them in a feed manufacturing process, as far as the way they were handled and processed throughout the entire feed mill?
So one thing with pulses, because they tend to have a high starch content, we did find just milling pulses on their own, they could get a bit gummy because of the type of starch present, and just their overall structure, say, compared to dried corn. There was a little more gelatinization during the grinding process on occasion. Same thing with pelleting, for example, especially when you started to heat it, as we found some gelatinization. Now, it wasn't too big of an issue, especially because generally, with the exception of, say, like human foods, where you're maybe making a puffed snack, we're not going to be just feeding a single pulse to an animal. So in a mixed diet, they're a lot easier to process. Something else we found, and this is actually in a couple of the publications as well. I am shamelessly slipping that in there. But what we did discover was there were some changes in nutrient content that we couldn't necessarily attribute to the processing, like in a chemical change, where we think it was more of a physical change. So, for example, although we cleaned out the grinder in between, we didn't necessarily keep what was left over. And one of our thought processes was we did see some differences between raw and ground when we analyzed them, from being the raw ingredient just ground through a small grinder on campus versus the ground product that went through a large hammer mill. And what we think happened was we actually lost some of the hulls during the processing, and we didn't see a consistent trend between ingredients, and some pulses have hulls that are more readily released. And so we think that maybe some of the pulses that have hulls that are more readily released, because the hulls are really light, they stay trapped in the grinder. And so we saw changes in nutrient composition, but it was more due to that fractionation again, because we're losing those soluble fiber rich hulls potentially, or losing some of that fraction of hull. So now we're seeing an increase in other nutrients such as protein, carbohydrate, minerals, because those are found primarily in that more nutrient dense inner seed portion.
Gotcha. So definitely some management on the grinding side that probably needs to be looked at as far as the product coming through. Gotcha.
But I also think it helps kind of, because what we tried to replicate was what would be happening in a mill. So not necessarily that very controlled individual steps where everything is completely changed out in between grinding runs, because we wanted to see, in a mill, if we're going to be feeding this to animals, we clean, we flush. For example, you might flush with wheat in between, but we're still maybe going to have some losses throughout. So I think it also gives us better insight than having that strictly controlled individual step every step of the way.
Sure. Absolutely. Again, my guest today is Cara Cargo-Froom from the University of Guelph. She's a postdoctoral researcher there. We're going to switch gears a little bit now, and I'm curious. I know in some of your work, they're working on your research projects, but also in some of your other aspects of things you've done. You've done a fair amount of work on kind of ingredient quality and analysis and things like that. And so I'm curious, from a perspective that you would have, having done some work, going across the industry into academia and research and all these things, what are some of the things that you've learned from the process of ingredient quality analysis, and the way that things are and should be done at a feed mill, for example, in order to make sure that we're looking at and obtaining our best quality ingredients coming in? And are there any things that you maybe have learned that you would consider not common or even potentially not popular ideas of things that are being done or are not being done that should be from that perspective?
Wow. So that's a great question. It's a big question too. I think in terms of ingredient characterization, the one thing I have to take away, and the biggest takeaway I have for everyone, is that we can only control so much on an industrial scale. On a laboratory scale, we can control, depending on the level of control you want over your experiment, we can control a lot of different aspects. But when you broaden that across laboratory to laboratory, and we can take that mill to mill, there are going to be differences. There's going to be differences in equipment. There's going to be differences in efficiency. There's going to be difference in size capacity of the mill. Is it a small mill that's servicing the surrounding area, or is it a large mill that's, servicing across, for example, Canada? And so I think one of the big things there is, depending on the equipment you have, there may be certain ingredients that you can better process compared to other ingredients. For example, I think if we take some of our peas, if you want to include hulls in them, then maybe looking at a roller mill or another type of mill where you maybe have less losses. Maybe there's more losses because we didn't compare mill types, but maybe a different mill might be more appropriate to process those pulses. You have hard to process pulses, so a lot of beans tend to be harder to process than, say, some of the peas, or it's harder to remove the hull. So again, considering, can your facility adequately processing these ingredients, I think is an important consideration, because you can bring the ingredients in, but if they're going to get gummed up, if you're just processing straight pulses, then it might not be an appropriate ingredient for your mill. So I think we have to look at the level of ingredient as well as just the differences across whether it's a mill or a lab that are processing and characterizing these ingredients, because even just over digesting an ingredient, if you're looking at amino acids for an hour, can change how much amino acid is going to be released during that digestion step. And so I think we can apply that to milling. Maybe you ground this ingredient for 30 seconds, where another mill is grinding it a little bit longer, or you're grinding it in larger batches. And so there's definitely a whole bunch of factors that influence it. But I think we can also take what we're learning and go, okay, we know from literature that these are easier to mill peas. So maybe these are more appropriate to include in an animal feed compared to these peas, or these peas have a better amino acid profile, so we should include them into this feed because the other ingredients complement it.
So kind of the idea there being that ingredient analysis, and therefore, ingredient choice, whether it be the ingredients themselves or the qualities of those ingredients, what we would accept, what we wouldn't, shouldn't be necessarily considered as kind of a one size fits all. The people and the processes being involved in making those decisions really need to understand the equipment and available processes at the facilities where it's going to be happening, because what might be an unacceptable moisture level of one ingredient for one facility might be able to be handled by another one. Or like you said, something that has a fair amount of holes on it it's got a nutritional availability there. And for this feed mill over here, absolutely put that in a formulation, and this can be your spec because they can handle it. But as good as it is, if you try to send it over to this one over here, it's going to cause so much of a problem that it's not going to be worthwhile. So that idea of kind of making that all part of that integrated decision making sounds kind of like what you're focusing on there.
Exactly. And I think if we step back even broader, I've had the fortunate experience to work over in our food science department a little bit. I've worked with staff at mills. I've worked with feed processing researchers, nutritionists, but what I see is although we tend to work together more, I think there can be more interdisciplinary crossover as well. So if we take our food scientists, they have a much better understanding of what's happening at the molecular level of starches than, say, the nutritionist. But we understand the ultimate outcome of if X happens and X happens, this is how digestibility, bioavailability are going to be affected. And then, of course, we have our the mills that ultimately understand how best these ingredients can be processed. And so I think there's still that disconnect slightly in between different disciplines where if we connect more, I think we can enhance feed processing. It's not to say we aren't doing well at the level we're at, but I think there's ways to better understand it, because I better understood what I was doing at the feed processing level when I could take it back to food scientists and work with them and go, oh, I see, this is what's happening.
Sure. Yeah, no, that's a great point. I think there's a lot of really interesting things there. And when we talk about it a lot here when we're making research feeds. And there are times where the feed mill or the actions around the feed that's being made, where there's times where it's a feed mill and there's times where it's a research lab. And some of that goes into what you're saying too, as well. Sometimes we're just measuring basic particle size or the durability or the hardness of pellets. And other times we're taking those pellets and we've scanned them with electron microscopes, and we've done all kinds of, looking at protein denaturation and everything else. And I think it makes for a very interesting part of our industry from the scientific approach, this being the Feed Science podcast, where we look at some things in a very macro level. How many tons of this can we produce in a given day? Because if we don't get 10,000 tons of feed a week out of this particular facility, we won't feed these animals. And at other times, we're looking incredibly micro, and we're talking about things like water activity and particle binding and surface tension. And so it's kind of fun to get to go all the way from the micro to a very, very large macro and look at everything from structural molecular things to things that are more like logistics and inventory management and everything in between. So, I'll switch gears one last time here. I think you mentioned, so some of the work that you're doing now is looking at like forage, digestion, and other things in equines. And it might be interesting for some of our listeners, when we talk most about feed manufacturing, and certainly research around it, we tend to focus a lot on the food animal production. So meat, milk, eggs, that sort of thing. And then there are those folks, obviously, that are producing a lot of equine feed, but it's not as big of a market. And so you've now gotten to experience a little bit of what it's like to do research with equines versus doing research with food animals, as well as some of the feed manufacturing. So I'd be interested in some of your perspectives on how different some of those things are when you're working with horses versus working with pigs and chickens as part of a kind of a research program.
So while I haven't been in a mill per se to work with the equine side of things, I'm primarily focusing on in vitros. What I have noticed is when we think about horses, they kind of straddle this awkward, they're not quite an ag animal, but they're an ag animal. But they're not quite a pet, but they are a pet. And when we look at the feed processing world, primarily they eat forage. So if you've got a good quality hay, many horses can do well. It doesn't require a lot of feed processing, but that's not to say forage isn't processed itself, even by the action of drying in the field and storage, et cetera, which to me, I also consider feed processing in a way. But I think we can look on the, for example, supplement side of things. There's a lot of supplements, and there are a lot of, I would say, pelleted diets for horses if you're looking to include a concentrate. Now, it's not, I wouldn't say it's a complete diet because, again, the way horses are built, they require forage in their diet. They're not like our dogs that can do extremely well off of kibble. So giving a concentrate only wouldn't be appropriate. But these concentrates can help enhance and supply nutrients that they might not be getting from a forage-only diet. Something else to consider is you can have products such as hay cubes or pellets that might be included, or again, supplements such as beet pulp that are pelleted. So while they might not be undergoing extreme feed processing or extreme temperatures like we might see with high temperature extruded products, there's still a level of processing that they're undergoing. And this might ultimately change the feed characterization between an alfalfa cube and the raw alfalfa forage. And so it's interesting to look into this because where we're coming from is we're looking at different ingredients that are being included either as concentrates or just feed supplements and equine diets. And there's a whole different variety. So when we think about processing, if you choose to include soybean meal, for example, that could be, it could be defatted or it could be full fat. So again, you're going to see effects of processing there. If you're looking at a concentrate like apple pomace, that's already gone through processing to get those fibers. It's extracted a lot of the sugars, the juices. So in terms of feed processing, we're still seeing effects of processing on the nutrients themselves and the ingredients themselves. But I think because it's from a supplement side, we maybe don't think of it or investigate it the same way we do for our companion animals or our ag animals, because primarily we're feeding forage. So we're concerned about the forage quality rather than the complete feed that we're feeding the animal.
Sure. Yeah, no, I think you touched on a couple of really interesting things there. The first is the obvious, like you said, it straddles this companion animal, ag animal, line there that makes the way that we look at how they're fed very different. The other thing I think that's very interesting when we talk about research on equine species is it's one thing, and you mentioned it right there that you're doing a lot of in vitro work, because on the food animal production, we do a lot of in vivo. Feed them, weigh them, collect eggs, collect milk, look at breast meat yield and all this other kind of stuff. And when we start talking about equines, as well as other things like exotic species and things like that, it's a whole different world of research, whether we be looking at something from the feed manufacturing side, particle size, pellet quality, uniformity of diet, whatever, or all the way down on the nutritional side of, how does this nutrient, whether it be an amino acid or an enzyme or whatever, impact the animal, because we can't do feed them and weigh them studies and things like that with horses. That doesn't work very well. That's and you don't go do that with a giraffe either. And so it makes for a really different, interesting, I think, approach to research, because you're having to take a lot of things, do in vitro lab work instead of in vivo live animal work, and do these extrapolations and best guesses and things like that, because it's harder to go, just feed them. So I think that's an interesting part of having to go from that food animal focus that you were doing with your swine and your pulses, and now going into something where it's like, okay, now this is a different game. And so it's a lot more stuff that has to be done in a different way.
Definitely. And I think too, it really helps highlight, because I like to say I have my fingers in a lot of different pies, or some people focus on one specific area. I seem to have been all over the board. It really just shows how, although we can focus on individual aspects or be primarily focused on one area, we do have to go back and look at that bigger picture and go from the very beginning of an ingredient all the way to the end. And that end could be simply how we're measuring it. And like you highlighted, there's a lot more challenges when you come to equine and companion animal research and what we're allowed to do compared to our agriculture research. And I think that also influences how we look at feed processing, because we can't always get as detailed of a picture as we can, for example, with my swine project, where I was allowed to be more invasive with these animals.
Yeah. Yeah, absolutely. There's, we're in the research and in the development, and this is equally true in the industry as it is in academia, in any kind of R&D, we're limited on what we know by how much data we collect and how we can collect that data. And that's always going to be harder on, species that are, a companion animal or limited availability, whether it, obviously there are all of the appropriate ethical concerns with, companion animals or exotics or anything like that. But it's also a numbers game too, right? I can put 2,000 birds into a house, into a floor pen study. Trying to do some sort of research where I'd feed 2,000 horses is no, thank you. That doesn't sound like a plan anybody wants to get involved in, right? And so we have to approach it very differently. And I think it's interesting, hopefully, to get some of that information out, not only to our world, but also into the consumer world of, hey, there's a difference between how much we know about feeding this and how much we know about feeding that, because we're limited by the data we can collect. So some of these things you have to take with a grain of salt, and some things that we just don't know how the interactions happen are because we're limited on the data. And so it's great that we've got folks like you that are like, okay, but what data can we collect on some of these limited species, even when it's a little more difficult to do it?
Definitely.
Well, thank you very much. And my guest today has been Cara Cargo-Froom from the University of Guelph, postdoctoral researcher there. Cara, thank you very much for your time. We've enjoyed having you.
Thank you for having me. It was wonderful to join you in this discussion, and I look forward to hearing the podcast live.
Very good. Once again, for Wise Genetics, I'm Adam Fairnolds at North Carolina State University, and this has been the Feed Science Podcast.